Shraddha Shah. We are here for the subject Computer Organization and Architecture. And in this subject, we are going to start with Unit 1, that is Computer Data Representation, Register Transfer, and Microoperation. And from this unit, we are going to start with topic that is Basic Computer Data Types and Complement. Before starting with this topic, let me see what are the outlines for this unit. What are the topics that we are going to cover in this unit? And these are basic computer data types and complements. Then we will see how you can represent your binary numbers in terms of fixed point representation and floating point representation. After that, we will see register transfer language and register transfer, bus and memory transfer, and then we will see arithmetic operation, logical operation, and shifting operation on binary numbers. And lastly, we will see arithmetic and logical shift unit. Okay, so let me start with our topic, that is basic computer data types. We all are aware that data are the numbers and other binary coded information that are operated on to achieve the required computational result. There are many number systems are available to represent the data. A number system of base or radix R is a system that uses distinct symbol for R digit, and the numbers are represented by a string of digital symbols. And for to determine the quantity that this number is representing, it is necessary to multiply each digit by integer power of R and then form a sum of all weighted digits. Okay, so let me see with one example. For example, if we have a decimal number system that we are using in every day, and that is radix 10, that means you can say base 10 system, and it is having total 10 symbols like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and okay. So we are having here total 10 symbol, and if we want to represent this string, that is 724.5, and we want to find out what the quantity this string represents. Okay, as we know, this is decimal system, so the quantity will be same, but to represent this quantity we require multiply each and every digit, that is 7, 2, 4, and 5 with according to its position power of 10. Why power of 10? Because this system is radix 10, and so it has a base 10. So here 4 is at 0th position, or you can say 10 raised to 0 powers position, 2 is at 10 raised to 1 power position, and 7 is at 10 raised to 2, or you can say 100th position. And similarly 5 is at 10 raised to minus 1 position. So to find out the quantity, we have to multiply this 4 with 10 raised to 0, this 2 with 10 raised to 1, this 7 with 10 raised to 2, and this 5 with 10 raised to minus 1. And we have to find out the product, we have to find out the sum of this product. Okay, this will be like this: 7 into 10 raised to 2 plus 2 into 10 raised to 1 plus 4 into 10 raised to 0 plus 5 into 10 raised to minus 1. Okay, so this quantity will be 724.5. But what if your number system is using radix 2, or you can say binary number system? Okay, so let me consider one example. If we say that if its system is a radix 2 system, that means it has only two symbols, that are zeros and 1. Okay, and if we have a string like this 1 0 1 1 0 1, and we want to find out what quantity this string represents in terms of decimal. So what we require to multiply each and every ones and zeros with power of 2 according to its position. Okay, so here this 1 is at 0th position, this 0 is at 1th position, this 1 is at 2nd position, this 1 is at 3rd position, this 0 is at 4th position, and this 1 is at 5th position. Okay, so here we have used a radix 2 system, that means our base will be 2. So we have to multiply each and every ones and 0 with power of 2 according to position. So it will be like this 1 multiplied by 2 raised to 0, this 0 multiplied by 2 raised to 1, this 1 multiplied by 2 raised to 2, this 1 multiplied by 2 raised to 3, this 0 multiplied by 2 raised to 4 and this 1 multiplied by 2 raised to 5. And if you equate this quantity, or you can add this all partial product, then you will get the quantity that is 45. Okay, that means this string 101101 represents the decimal quantity 45. If you want to represent 45 in terms of decimal, you can write like 4 and 5. And if you want to represent this quantity in terms of binary, then you have to write like 101101. Okay, quantity will be same, but representation will depends upon your number system, which number system you have used. Okay, this decimal and binary are not only two number system that you can use. There are so many number of systems, like you can use octal, hexadecimal, BCD, and so on. Okay, for example, you are using octal number system, then it is a radix 8 number system. Hexadecimal number system is a radix 16 number system. That means it has a total 16 symbols. Okay, how the system works, let me see. For example, if we consider the octal number system, that is radix 8 system, and it has a total 8 symbols like 0, 1, 2, 3, 4, 5, 6, 7. Okay, and for any number system, whenever you are going to use this with a digital system, you have to use the binary conversion of that number. Okay, so for this octal representation, we have total 8 symbols, and to represent 8 symbols in terms of binary with different bit pattern, you will minimum require 8 patterns. Okay, so for this we have this kind of 8 pattern. For 0 we are going to using 000, for 1 we are going to using 001, for 2 010, and so on up to 7 we have 111. Okay, and if you have a string of this octal number like 10, 11, 12, 143 kind of that, so at that time you have to consider each and every octal number as an individual octal number and convert that number into binary. For example, if we consider number 62, so we have to consider this 6 as an individual binary number, 2 as an individual binary. Let me consider string 62. Okay, so for this 62 string, you have to consider 6 as a different octal number and 2 as a different octal number. Okay, so for 6 we have binary pattern as a 110, and for 2 we have binary pattern 010. Okay, so by this way, by using this 6-bit representation, you can represent this 62 quantity and so on. Okay, next, let me see what is for hexadecimal number system. Hexadecimal number system is a radix 16, or you can say base 16 number system. So it has a total 16 symbols to represent this number system, and the symbols are 0, 1, 2 up to 9, and then A, B, C, D, E, and F. You have total 16 symbols, and whenever you considering this with the digital system, you have to convert this into binary system, and so for that conversion you will have total 4-bit representation for each and every symbols. As we have total 16 symbols, and we can represent the 16 symbol by using 4-bit binary pattern. So for 0 we have 000, for 1 we have 0001, and for 2 we have 0010, and so on up to 9. For after that we are going to using A, B, C symbols. Okay, so for A we have 1011 and so on, and for F we have 1111. Okay, so all patterns you can perform by using 4-bit representation we have used, and we have assigned to each and every hexadecimal symbol. Okay, so by this way you can use hexadecimal number system. If you have string of hexadecimal numbers like F8, 63, 32, so at that time, similar to octal number system, you have to consider each and every hex number as an individual number and convert that number into binary. So for example, for 63 you have to consider 6 as a different hex number, 3 as a different hex number, and convert 6 into its equivalent binary and 3 into equivalent binary. So you will have for 6 as a 0, 1, 1, 0, and for 3 as a 0, 0, 1, 1. Okay, so by this way you can convert any hexadecimal numbers into its equivalent binary number. One another system that we are going to use is a decimal number system that we are generally using. Okay, in this system we have total 10 symbols. Okay, and that is 0, 1, 2, 3 up to 9. Okay, only numbers, and it is also known as a binary coded decimal, that is BCD. Okay, and we have, if we have a string of BCD numbers, then we have to consider individual numbers and then convert it into its equivalent BCD code. Okay, for example, for 99 we have 1001 and 1001 individual 99 bits. Okay, so by this way we can consider a BCD number system. Okay, so you can use any number system, whatever you require, but ultimately you have to convert it into its equivalent binary, and that will depends upon your number system, how you have designed your code. Okay, so next we are going to see with complements. So the complements we are using in digital computers are generally for the simplification of subtraction operation, and you can also use this for logical manipulation. As we are aware that there is no circuit that you can design like uh, subtract. Okay, you can do subtraction operation but by means of addition. Okay, and for this addition you will require the complement of subtrahend. Okay, and this complement can be two types, like r's complement and r minus 1 complement for base r system. Okay, and for different representation of r you will have different complement, but each and every system will have two complements. For example, if we consider binary number system, that means it will have base 2, that is 2. Okay, so it will have two complements like 2's complement and 2 minus 1, that is 1's complement. Okay, if we consider decimal number system, that is base 10 system, so it will have r's complement, that is 10's complement, and 10 minus 1, that is 9's complement. Okay, and similarly for hexadecimal and octal number system, for octal number system you will have 8 complement and 7's complement, and for hexadecimal number system you will have 16th complement and 15th complement. Okay, so for us, we are as we are going to using digital machine and that are always going to work on a binary numbers, and we are designing hardware in this course, so we will require generally 1's complement and 2's complement. Okay, so let me see how you can design 1's complement and 2's complement of the binary numbers. Okay, so for 1's complement you just require to interchange zeros and 1 in your binary string. If you are given a binary string and you are told to convert this into its 1's complement, so you just require to interchange ones and zeros. Okay, and for 2's complement you have to add 1 into its 1's complement. Okay, this will be more clear when we will see one example. So let me have one string, that is 1 1 0 0 1, and we want to convert this string into its 1's complement and 2's complement. So for 1's complement you have to interchange zeros and 1. Okay, so here we have 1 1 0 0 1, so in place of this one we have to put 0, for this 0 1, for this 0 1, for this 1 0, and for this one 0. So we will have 0 0 1 1 0. Okay, as its 1's complement. It is simple, just complement ones and zeros. For 2's complement we have to add 1 into its 1's complement. So we have to add, we have 1's complement as 0 0 1 1 0, and we are going to add 1 into its 1's complement, and we will get like 0 plus 1, that is 1, 1 plus 0 1, 1 plus 0 1, and 0 and 0. Okay, so we are getting 2's complement as 0 0 1 1 1. Okay, so it is so simple. For 1's complement you have to interchange zeros and ones, and for 2's complement add 1 into its 1's complement. Okay, so by this way you can find out the 1's complement and 2's complement of any numbers. So we are ending our today's session over here. If you have any query, then contact me or write in a comment box. I will try to solve your query as soon as possible. Thank you for watching.